Hey, Welsh Dragon Metals here. Today I'll be pouring a tin antimony alloy ingot. Here's the crucibles already loaded with a piece of antimony and a chunk of tin. There's also some borax in there. And I will be pouring it into this ingot here. It's the type of gas I'm using. This is antimony. Very shiny material. Very crystalline, almost really difficult to melt on its own, and pretty much sole uses in alloys, such as making lead-free solders for welding. And I also have my temperature gun, so keep an eye on the temperature. Get a nice angle. I can use some heating. Mould still a bit warm. Won't take long. Sure the antimony alloys with the tin properly. The chunk is still there. There's yet alloy with the tin. There it goes. A little bit more heat upon it. Borax in here is helping clean it up. Melting that antimony chunk into it. As you can see, it takes a little while to alloy. This will make the bar a bit more valuable, much more shiny, while maintaining its conductivity. It's good for welding, electronics and such. Got some glossy material there. Get rid of that. Very shiny, as you can see. Let's pour that. Change the angle so you can get a better view. Use my other hand, otherwise you won't get to see these whole pouring. Rotating the mould so I can pick it up. The spout's the right way round. All the liquid has been passed into the mould. That will need a little bit of manipulation. The mould is obviously not high enough temperature yet. Has made a very nice bar, however. Quite a lot of antimony in this tin. Putting that bit of dross off there that I can see, whatever that is. Dirt. Okay, so in a nice liquid state now. Give that crucible a clean while I'm got the blowtorch lit. There's still some metal material in there, as you can see. Trapped within the borax. If I just heat this for a while, the borax will solidify into a little pool. Wow, there's steam coming out of my breath. I guess it's cold today. And we'll make a nice little pool of metal at the bottom. You see it glowing there, that's liquid borax. Boron, just a type of glass. So it's floating on a little bed of glass, basically, in metal. Manipulating it around the edges using a steel spoon, as the steel will definitely not melt at this temperature. Little bead of metal there formed. There we go. And the crucible's nice and shiny for next time. And there's a little bead of metal there that I can use to alloy into other stuff. That bar's still cooling by the looks of it. Yep. Rather not touch it until it's fully cooled. Take my goggles off now. Let's check the temperature on the crucible. Ooh, that's high. So nearly 500 degrees on the crucible. Enough to melt the borax. It was obviously much hotter just now when I had the blowtorch going. And the mould is quite low temperature. Although this is low temperature melt solder. So about 200 degrees the mould. Dropping fast. Very fast, as you can see. It's an infrared temperature gun. Doesn't really work on reflective materials, which is why I have to try and aim it at the crucible or the mould itself. That's because it needs light in order to tell the temperature, and reflective things really difficult to tell the temperature. That's just solidified. Could use a little bit more heat on the top. Some strange patterns appeared that I don't like. They're handy, them electric igniters on them blowtorches. Otherwise you get one with them, although you'll be lighting it all the time. Wow, there's a spider in the forge, and it's fine. Seems to like the heat. Cold-blooded creatures. Creepy. Seem to have liked my new rebuilt furnace area. Well, that is incredibly shiny from here. Hope you can see that. Move it to a cooler part of the brick. Let's have a quick examination. Well, my phone is quite hot. Only blowtorch. So there's the ingot. It's cooling right now. Let's check the temperature. Temperature is dropped quite a bit, but not as much as you would think. It's cooling quite slowly, but it is pure graphite. Even though the mould is not that big, the walls are quite thick upon the mould. You can see that. They're about 1 centimetre thick all the way around. Maybe half a centimetre on the sides. A bit less, or a bit more. So quench that next. I will be stamping this with a custom design. I will post an inspection video of that once I have stamped it, as I must also polish it and give it a buff. And after I add some ink, I must polish it and buff it again. It seems nice and cool. It's quite cold out here today. It is a nice winter's day. Ah, that is one beautiful looking ingot. Look at that. Woo! That is like extremely well formed. Give that a dip in the water. Quenched. Very slight pock mark on the edge, but that's fine. The shape is very, very uniform indeed. Look at that. That should stamp lovely. We'll be stamping this as a binary themed bar, so 01010, and I will most likely put green ink upon all the lettering, numbering. Very nice piece, hope you agree. High antimony tin alloy. See how much it weighs. Got it set to ounces there. So it weighs 1.2 ounces, so let's say the 15 is water yet to evaporate. So, 1.2 ounce. Very shiny bar, very nice. It's actually a lead-free solder type alloy, worth a little bit. And so they was pouring tin antimony alloy. And there's antimony in there. Shiny, strange material. Well, till the next video.